Hey everyone! In today's video we're going to be talking about solving exponential equations. In this video we're only going to go over the basics and talk about what is an exponential equation and doing some really quick examples. Let's consider the expression 2 to the power of x equals 2 to the power of 3. You are tasked with finding what is the value of x. If we want to read this as a sentence, 2 to the power of x is the same thing as 2 to the power of 3. We can then determine that x has to be the same thing as 3 because they are the same powers. This is the exact same thing. Therefore, x is equal to 3. We can do a quick check here. We can say 2 to the power of 3 and replace that x with a 3. Well, that equals 2 to the power of 3. And just by looking, just by observing, I can see that the left-hand side here is the exact same thing as the right-hand side. But I can go one step further. I can say 2 to the power of 3 is 8. 2 to the power of 3 is 8. 8 equals to 8, and therefore I have found my correct answer. What we just did is called solving exponential equations, because we are looking for what x equals, and x happens to be an exponent. In previous math classes, you have seen where x is just a regular old number and you need to use opposite operations, but these are a little bit trickier because we are dealing with an exponent. In order to solve these questions, we need x on its own, so just like here where x was on its own up top, and the same base attached to x. So the 2 and the 2 was very key in us being able to do this. If we had had a different base value on the right hand side, we would not have been able to solve this problem as quickly. A note that x can be positive or negative. And in order to solve these types of problems, we need to use the implies that symbol, which looks like a little sideways arrow. It's like an equal sign with an arrowhead. I'll show you how to use that in our examples here. Example number 1, 3 to the power of x is equal to 3 to the power of 6. Okay. Well, we already said that we can just kind of ignore our bases and only look at our exponents. And so I'm going to say this implies that x is equal to 6. That's the only way for this expression to make sense. How about here? 4 to the power of x is 4 to the power of 2. Well, that must mean x is equal to 2. 5 to the power of 3 is equal to 5 to the power of x. Well, that implies that 3 equals x. Negative 2 to the power of x equals negative 2 to the power of 5. Again, we're just going to ignore the negative 2. That doesn't change anything here. This just means x equals 5. 1 over 3 to the power of x equals 1 over 3 to the power of 4. Well, this implies that x equals 4. 3 to the power of x is 3 to the power of negative 2. Okay? We're okay with negative numbers here. We just ignore the 3's. X equals negative 2. Negative 4 to the x is equal to negative 4 to the negative 3. That's okay. Ignore the negative 4's. We're just going to write x is equal to negative 3. Finally, 2 over 3 to the power of x equals 2 over 3 to the power of negative 4. Well, this implies that if we ignore our bases, x equals negative 4. Okay? All we were doing was grabbing the number that was on the other side of the equation and setting it equal to x. And the reason that I was able to do this was because the bases on both sides of my equation were the same. In our next video, we're going to talk about dealing with situations where the base is different.